Hello, in my previous video we learned what is a capacitor and how it works by practically doing it. That is, we made a simple project to learn how a capacitor works. But in this video we're going to learn more in detail about this capacitor, about how it works and what's inside it. So let's quickly go into the video to learn what's inside this beautiful thing. So what is a capacitor actually? Well, a capacitor is an energy storage device. That is, it has two terminals as you can see, namely positive terminal and negative terminal. So if we connect a battery to these terminals respectively, it will store the battery's power for a specific period of time, that is either for 5 seconds or 10 seconds, the whole of battery's power. And when you remove the battery and connect any load into it, that is an LED or something, it will light that LED for that specific period of time, about how much energy is stored. So basically a capacitor looks like this. It is cylindrical in shape and it has two terminals, that is mainly positive and negative. So if you have a doubt in identifying which is negative or which is positive, then you could see the side of the capacitor here, which has a negative marking here, that is minus marking. So the terminal that is close to this negative marking it is termed as the negative terminal, and opposite side is the positive terminal. So you could identify it by looking on its side itself. And the capacitor comes in various sizes depending on its storage capacity. So this is a smaller capacitor than that one. This is a fatty one, and this is called a ceramic capacitor, which is a special type of capacitor which doesn't have any polarity. That is, it has neither positive or negative terminals. You could either connect its terminals either and this is the special type of capacitor which is called a ceramic capacitor. It has no polarity, that is, it has no positive or negative terminal, and you could connect its terminals to either pins of the battery and store energy or filtering any noise. Okay, now coming to the main capacitor. So when you see the side of the capacitor, you could see that it has two markings or two numbers, that is 1000 and one symbol, and 25 and volts, V symbol, that is volts. So what are these? Well, the first one, that is the 1000, this is called a microfarad. So the U like symbol is called micro and F is called farad. So the 1000 microfarad is the capacitance of the capacitor. That is, capacitance means how much energy it can store. So if this value is higher, then the capacitance is more, that is, it could store more energy. If it is low, then the capacitance is low and it cannot store more energy. Like this small capacitor which is only 10 microfarads, and it could not store much energy than that big one. And now below it, that is written as 25 volts. So this is the maximum voltage that this capacitor could handle. If you go beyond it, then you may know what would happen if you saw my previous video. And it will not only burst if you exceeded its voltage. If you change the polarity, that is, you connect positive to negative and negative to positive, your capacitor is bursted. You can see my previous video where I have made this mistake. As you can see, there is a dent on the top, that is, you have an X marking on the top. Do you know why? So if you have seen that bursting, the capacitor may have exploded and released a huge amount of smoke and sound. The capacitor, and let's see how much backup it gives. Come. Okay, now we're going to charge the capacitor using my power supply that I had built before. Now we're going to charge it. First plug it in and then switch it on. Is it charging? But if you have this dent, it will delay that. That is, this dent will first release some lot of smoke or some of the smoke, which will warn you that the capacitor is gonna burst. And if you ignore that warning, then it will burst like that capacitor too. But small capacitors do not have this dent, as you can see. So it will explode immediately as soon as you make a mistake in it. So that's why bigger capacitors have this dent. If they burst like the smaller ones, they will create an atomic bomb or something. Now let us take a quick peep at what is inside the capacitor. So inside the capacitor there are two metal plates. One is a positive metal plate and other is a negative metal plate. And now these metal plates are good conductors of electricity. That is, they allow electricity to flow through them. And on the center there is an insulator called dielectric. And insulators does not allow electricity to flow through them. Now, how a capacitor works? Well, on one side, that is on the negative metal plate, there are more electrons here. and on the other side there are nothing or less electrons, and these electrons are stuck in here and want to go to the positive side, so that they can be free. But they have a way to go from this to here, but there is an insulator here which does not allow electrons or electricity to flow through them. So these electrons are stuck in here and cannot go through this directly. Now when we connect a battery to the terminals of the capacitor, the electrons have a chance of going to this battery and coming to this positive side. So they all go pass through the battery and come and collect in this positive side one by one. Now when the positive side is filled with electrons, the negative side is, that is, they have no electrons or only less of them. So now the positive side is full, so this means that the capacitor is charged, and now the capacitors are stuck in this positive side and wants to go to this negative side, which is free. So now even if we connect a battery, the electrons may not be able to move. So for the positive electrons to go to this negative side, we connect a load, that is, in this side we connect an LED. So now the electrons have a chance, that is, they go from the positive side, pass through the LED and go to the negative side and slowly collect here. So as the electrons slowly collects, the LED glows when the electrons are passing. Now when the electrons are fully collected in this negative side, the LED stops glowing, and now the capacitor is said to be discharged. That is, the negative side is full of electrons, but the positive side has nothing. So now when we again connect a battery here, the capacitor gets charged, and when we connect a load, the capacitor gets discharged. So this is the way how a capacitor works. And I previously said that we should not change the polarity, that is, connect the positive to negative terminal and vice versa of the capacitor, and do not exceed the voltage limit. Why is it so? Well, the first, do not change the polarity. So now when we connect the battery's positive to the capacitor's negative, here there is a negative metal plate here, and that is full of electrons, that is, say, negative electrons, and inside the battery positive electrons are flowing through this. So now here negative and positive electrons are getting mixed, so which creates a short circuit, and it is a negative metal plate also. Here there is a positive terminal, so positive and negative creates a short circuit inside the capacitor. That's why it explodes. And why we should not exceed the capacitor's limit. Say the capacitor is rated for 10 volts, which means that the inside of the capacitor's components, that is the metal plates, insulators and thingies, are only rated for 10 volts. If we exceed the voltage, say 15 volt or higher, then these metal plates will get heated up very quickly and explode. That is all about capacitors. So I hope that in this video you would have learned how actually a capacitor works, what is inside a capacitor. And if you want to know how actually a capacitor works by making a simple project or learning it practically, then check my previous video, and don't forget to subscribe and like to get more videos like this.